AGI will not be created by humans. The popularization and rapid development of artificial intelligence allow to consider not only philosophical, but also technical aspects of general artificial intelligence, strong artificial intelligence, AGI or superintelligence. Whatever you call it, the direction of development is the same. And in the long run, there are apparently very few fundamental obstacles to achieving this goal. The right question is not if, but how and when large language models, or perhaps in the face of multimodality, just models, will reach this level of development. I cannot say when this will happen, but I see two trends that clearly indicate the way to the goal. The challenges of developing artificial intelligence are, of course, many, both at the technical and organizational levels. Starting with the huge computing power needed to train leading large language models, the choice of the right neural network architecture, the whole gigantic area of security, and many others. In contrast, the larger the language models we create, the more visible two things become. First, it is clear that an enormous amount of data is needed to train the models. There have already been sighs that we are able to store all the books created by humanity on a single hard drive. And then there are the growing problems of accessing the data, after people realized how valuable it is now, and the related rising battle over copyright in AI learning. The second thing is the costly and growth-slowing human participation in the training process. To keep the quality of the model, it is necessary to evaluate the results. Commonly used for this is the so-called reinforcement learning from human feedback. The human evaluates whether the result that the artificial intelligence returns is the expected one or not. And just the right approach to the above challenges can allow it to move to the next level. What is synthetic data? Yes, synthetic data is rising to the status of the holy grail of the whole AI. What is all the buzz about? What is this mythical synthetic data? It's simply data that wasn't created based on real-world events, but was generated artificially. Fictional data, which is less useful for AI, the one created based on some algorithm, or generated by artificial intelligence. Sounds perfectly innocent, doesn't it? But let's start at the beginning, yes, with the Go game. Go is a game in which humans kept their dominance for a very long time. This was due to its complexity, or more figuratively, the large number of branches, or otherwise the possibility of making the next move. As a result, traditional search algorithms performed less well than in other games. The year 2016 is considered a breakthrough, when the AlphaGo program, based on neural networks and machine learning, defeated the champion Lee Sedol. However, the real breakthrough came a year later with the arrival of AlphaGo Zero. No data from historical games played by humans was used for its training. Instead, AlphaGo Zero played against itself and learned from those games. The level of the version that defeated Lee Sedol AlphaGo Zero surpassed in just 3 days. After that time, Zero was winning against the previous version, 100-0. Just a few months later, DeepMind created Alpha Zero, a general version. It, after only 24 hours of learning only on its own games, with no other input, beat the human level in Go, Shogi, and chess. Outclassing, by the way, all previous programs playing these games. It was a spectacular demonstration of the power of synthetic data. Alpha Zero became the basis for more serious applications, such as AlphaFold, which was used to predict protein structure based on amino acid sequences. Those who are interested in artificial intelligence have probably already heard about AMI, Articulate Medical Intelligence Explorer. This is a Google research project that created a chatbot that focused on diagnosing potential diseases just by talking with patients. What hit me most when I first heard about the project was not that a mechanical doctor was better at diagnosis, but that humans were losing the competition in the empathy category. On the other hand, when I became thoroughly interested in the topic, it additionally turned out that AMI is based on synthetic data. Initially, they relied strictly on audio transcriptions of physician visits. However, it turned out that this was not ideal data, due to the absence of the entire spectrum of medical conditions, imprecise answers, and unclear language. Slang, jargon, sarcasm, ungrammatical answers. Therefore, they based themselves on synthetic data and conversations generated by AI agents, the doctor and the patient. The dialogues generated in this way were based on a database of medical conditions, thus providing a comprehensive set of diseases. And it was the use of synthetic data generated by AI that was able to provide training for the model, which was able to achieve much better accuracy in diagnosis than a primary care physician. The Achilles heel of large language models has been mathematics for a long time. It seems that through some imperfections in the logical reasoning of the models, it is difficult to achieve good results. In contrast, another limit has also been overcome by synthetic data. Launched recently by DeepMind, alpha geometry is able to compete with the winners of the math Olympiads, at least in the field of geometry. In the case of alpha geometry, 100 million cases generated specifically for the learning process were used for training. There's no doubt that here too synthetic data helped achieve mastery, although of course this was not the only innovation of this project. Well, but we can say that these are very specialized cases, where it is relatively easy to imagine generating synthetic data. With training to bring us superintelligence, we would need very general data from different fields of knowledge. It is possible to picture a situation where artificial intelligence generates data, on the basis of which it then learns, while this data would be generated, after all, on the basis of the knowledge that the model already has. Isn't this a vicious circle? Well, it may seem so at first. On the other hand, let's consider how much of our knowledge, experience, intellectual capacity is due only to external knowledge, and what part was gained through our own thinking, systematizing and analyzing the knowledge we already have, solving complex problems or mathematical problems. To what extent would our knowledge, behavior be the same if we read thousands of books without thinking about their meaning? From this point of view, does synthetic data make more sense? Self-learning artificial intelligence. Anyone who has considered the future of artificial intelligence must have asked themselves at least once, can AI create an artificial intelligence more perfect than itself? Intuitively, we often deny such a possibility, or at least many skeptics do. If it were not possible, it would actually also have to be assumed that humans are incapable of creating superintelligence. A week ago, a study was released on self-rewarding language models. As the name implies, it describes a self-rewarding language model, that is, one that evaluates its own performance in the learning process. In this case, it is based on Llama 2. Again, intuitively, we may think that it doesn't make sense, because a human being is needed to prevent the model from reinforcing imperfections. After all, no one should be the judge of his own case, right? Or at least he won't maintain objectivity. Well, it turns out that this is probably not true. The authors of the experiment prove that the third iteration of the model, trained with self-assessment, achieves significantly better results. Nearly 63% of responses are considered more accurate than the baseline model, while the reverse is true in just less than 10% of cases. It is also evident that the comparison from generation to generation also always comes out favorably. You might ask, where did these percentages come from? And rightly so. This is where, in my opinion, the only significant doubt arises. The evaluation is based on Alpaca Eval, a model that measures the accuracy of language models' responses. Of course, it could be that the choice of a benchmark influences very positive results, while there are many indications that this is a good way to go after all. Where will this take us? Many of the studies I've mentioned are very recent, so it's difficult to conclude with certainty. In my opinion, however, everything points to the fact that we have already started the process in which artificial intelligence improves itself. That's right. For the time being, a lot of human participation is needed in this process, and for the time being, these are also experiments. However, it can be assumed that the next generation of artificial intelligence will develop itself. We initiated the process and will be the creators of the first generation, while in developing the next generation, artificial intelligence itself will be more effective than us. The path seems to have already been set, and synthetic data and self-assessment mechanisms in the training process are what we will need on it. Or, actually, not exactly we,